Okay, today's video we will be deriving the derivatives of the inverse trig functions and seeing their applications to integration in a later video. But today we will just be deriving the derivatives of sine inverse, cos inverse, and tan inverse today's video. So first we're going to cover sine inverse, second we're going to cover cos inverse, and you know what it is. So first of all, y equals sine inverse of x. This derivative can be found simply by doing the property where sine of sine inverse of x will just be x by applying sine to both sides. Now you can find dx dy because you're differentiating x with respect to y, which would just give you cos y, because that's your standard trig identity formula. Dy dx would be 1 over cos y this time. The reason why we can just flip it like a fraction is because this can be technically treated like a fraction, but there's a proof behind this, and we will cover this later on in another video, the proof of why this occurs. But now the other question is, how do we get the standard trig function of this? How do we get the standard derivative? How do we transform this all the way to that? It just makes no sense. But if you think about it properly, you can recall sine squared y plus cos squared y equals 1, right? This is your Pythagorean identities. Make cos y the subject equals positive negative root 1 minus sine squared y. The reason why I am not instantly jumping into a positive is because I need to explain to you why the negative is removed. The negative is removed because of the inverse trig function range. It restricts it, and therefore you can only have the positive value. So this is why cos y will simply just equal to root 1 minus x squared. This comes from this. We just used remember from the first step, and now we simply sub it in. Dy dx will just simply equal to 1 over root 1 minus x squared, and now this is a derivative of sine inverse x.